So let's say you want to add a NOT gate on your breadboard or your prototyping circuit that you are building together, but you do not have an actual NOT gate, physical NOT gate chip or something laying around to use, but you do happen to have a NAND gate available. Well, I'm happy to tell you that you can construct a NOT gate out of an AND gate, so you can achieve that inversion functionality. So we know that a NOT gate inverts an input, takes an input and inverts it to the output, and the NOT gate has only one input, one output. And so 0, 1, 1, 0. Now we know the NAND gate is an AND gate with a with inverted logic. So technically this looks like this. An AND gate takes 2 or more inputs and provides one output. So we know that with an AND gate, the AND gate only outputs 1 when both inputs are 1. So if you use this truth table and apply, some logic to it, we can come up with the NAND gate truth table. So we know the NAND is an inverted AND. So using that truth table, we will see that when both inputs are 1, it actually outputs 0. However, in all other cases, it outputs 1. Now, let's look at 2 cases on this truth table for the NAND. I want to look at this case here, and I want to look at this case here. Do you see where when both inputs are 0, the output is 1? When both inputs are 1, the output is 0. So the inputs are getting inverted. Using this logic, we can actually do something neat. Let's say we take this NAND gate here, right? And we have these inputs here. Let's call this input A, input B, Y. If we tie these inputs together and give it, let's say, a signal, right? Sorry, this looks hideous. So if we tie both inputs together and let's give it a 0, a 0 input here, right? When you give it a 0, this 0 is going to go to both A and B. And by looking at the truth table for the NAND, the output for this is going to be 1. Voila, we inverted it. We had 0 on the input here, input, output. We had the 0 on the input, and we achieved 1 on the output. Let's give it another value. Let's give it a 1, right? So the 1 is going to go to both A, it's going to go to B, and by looking at the truth table for the NAND, we see that when both are 1, the output is 0. So voila, we gave 1 input, we received 0 on the output. So that's pretty much how you can achieve a NOT gate by using a NAND. So to recap it, this bad boy here on the left can be constructed using a NAND gate. Your NAND gate, in order for it to achieve the inversion capability or the NOT functionality, both inputs must be tied in together. It will look like this, or it will look like this, or whatever. And that's it. Thanks for watching.